All right. So, hope everyone had a restful long weekend. Okay. So now, what we are going to do this week, it's something more applicational, which is a good tool in case you have to use it. Now, for first thing, we have the law of sines here, law of sines, and now let me before we go over this, do you remember from your geometry class? Okay, before you shake your head, just hear me out. Do you remember that if you have a bigger angle, what does it say about the opposite side? If you have a bigger angle, okay, for example, if I draw a triangle right here, so if I have a bigger angle, what does it mean to the opposite side? Supposed to be longer, okay? If it's the biggest angle, then the opposite side must be the longest. Well, longest. Well, if it's called hypotenuse if it is a right triangle. So that should come hand in hand since you brought up the word hypotenuse. Well, we say that this hypotenuse is the longest side of a right triangle because, well, the right angle is the biggest angle, right? So back in geometry time, we talked about the relationship very qualitatively between the angle and the side. We just say the bigger the angle, the longer the side. There was never anything quantitative. So today, we are going to put a quantitative lens to describe the relationship of the magnitude of the angle and also the magnitude of the side. And that is called the law of sines. Now, I want to make sure that you have a good lens to look at this. Here, we have sine of an angle over the opposite side. Now, I want you to draw a little triangle here. Oops, triangle. Okay. All right, so just say A, B, and C. And I just want to make sure that everyone is having some good memory in terms of labeling sides. Well, so the capital letters would be used to label the vertices, okay, or the angles, A, B, C. We'll use small letter to label the side. So which side is the side A? In between which two vertices? In between B and C. Okay, that would be side A. So whenever we label the side, it's always opposite to the angle. Okay, I want to make sure that everyone is good with the labeling before we move ahead. So in this case, our small letter B would be between A and C. All right, that would be your letter B, and your letter C would be the one at the bottom. Okay, so just have to be very focused. If not, it could cause some confusion here. So making sure that you label this. So what you can see here, the quantitative relationship between the angle and side is that when you have sine of an angle over the length of the side, they're always proportional to each other. Okay, so the angle and the opposite side, well, the sine of the angle over the opposite side, it's always equal to the other combinations. Now, at the same time, I also want you to write down the alternative expression. Okay, this also works. The reciprocal can work as well. Oops, sorry. And depends on what situation you're dealing with. We'll use these accordingly. Now, we don't have to write all three together. Okay, what we're showing here is that these three angles and these three sides, they have this relationship together. All right now. Okay, let's write down these angles, and then I'm gonna draw. Now, try to draw a triangle. Okay, try to draw a triangle for this first example here. And you can go ahead and label A, B, and C. Okay. So now before we do anything, let's go ahead and label all this, all the given data. So we have angle A, that is 42 degrees, angle B being 57 degrees, and the length C, we use another color. This is 67. Okay, this is C equals to 67. Now, before I go too much further, let me ask you a question. Is there any information right here that you can obtain, but it's not listed or labeled here at this moment? What is that piece of information? Angle C is what? 180. 180 degrees minus 42 minus 57. Okay. So that gives you 180 degrees minus 99. So that means the angle here will be 81 degrees. All right now, and this is part of the technique of problem solving, and that is whenever you see some given situations, these conditions, you always ask yourself, is there anything you can obtain that's not currently listed at the moment? Okay. So now, and then it says to solve the triangle. What does it mean by solve the triangle? That means find all angles and sides. Okay. You have to find all angles and sides. So let me go ahead and label our side A and side B. So we have all three angles already. So all we are missing is just two sides. Well, and since we have these angles, and now we can go ahead and use our law of sines. Now, if you look at the box, it says the law of sines is used when we are given two angles and one side. Okay. Now, I do want you to highlight this part, two angles and one side. And I would also like to tell you that I am not a big fan of this. I am not a big fan of this for two reasons. One, if you memorize these two, the ASA or AAS, it's so easy to get confused. Number one, that's number one. Number two, do you remember when we used these acronyms back in the days? Yeah, to prove it is to prove if two triangles are either similar or congruent. But this is not the case. And I'm not interested in confusing you guys with these acronyms. So what I would say is this. Today we will learn this law of sines, and all you need to do is this. Actually, I want you to write this down on the side. The law of sine requires the condition that allows you to use law of sine is that you have to have two sides and two angles. Two sides and two angles, and one of these four is an unknown. Okay, so actually, yeah, two sides and two angles. Two sides and two angles, and one of them, it's unknown. Okay, and then you can use the law of sines to find out. So in this case, we say, yeah, we have all the angles and we have one side that's given, which is lovely. Then we say, all right, let's go ahead and find out our side A. Now we can say side A over sine of A, it's equal to, well, we don't know B, so let's go ahead and use C. C over sine C. Okay, use what's available. And we say, all right, once we write down the equation, we have A over sine of 42 degrees, and then 67 over sine of 81 degrees. All right, now I would, yes. Well, that's why I wrote down here the alternative version. Okay, if you do the reciprocal, that works too. Okay. Now, what I like to do usually is I like to, and the reason why I gave you this alternative version is because I want to save your work. I don't want you to deal with the situation where your unknown is in a denominator. That usually causes a lot of chaos. So if I want to write down a calculator ready version, okay. And then now, if you need to use a calculator, you can come up here and get a calculator. And make sure your calculator is in degree mode. Okay, so now we are doing these application questions. We are doing this in degree mode, so make sure you change it to degree mode. So you have, let me see, I get my calculator. All right, new calculator. So you have what? 67. You have 67 divided by, wait, hold on. Let me change to degree mode first. Degree, done. Okay, sine of 81 degrees. Okay, and then times sine of 42 degrees. And you may want to use, yeah. So you should get 45.39. So your A, it's 45.39. Okay. Right, making sure that you have the degree mode and just type it in. Okay, 67 divided by sine of 81 degrees and then times sine of 42 degrees. So give you the answer pretty easily. And then you may go ahead and try to find out B. Well, the way we find out B, it's very much the same as the way we find out our A. So we don't know what B is. So we say B over sine of angle B, which is 57 degrees. And then C, it's 67 over sine of 81 degrees. So B is equal to 67 over sine of 81 degrees times sine of 57 degrees. So side B would be louder. Yeah. 56.89. That would be your the other side. Now I would always ask a question here. Okay, the question I would like to pose here is how to know if the answer makes sense. Okay, well, As we said in the very beginning of the class, what you learned back in geometry is that the bigger the angle, the longer the side. And if you look at the angles right here, angle C, it's the largest. So length, the side C must be the longest. So when you calculate your side A and side B, they should be smaller than C. Okay. If you get the numbers that are smaller than C, then at least you can have a little bit of reassurance that it's going to be correct. Okay. If you have anything that's larger than the side C, then you can stop right there and go back and check, because that cannot be right. If you get a negative number, that's even more strange. Okay. All right. So let's go ahead and move on to the next one. Now, for the next one, we have a little obtuse angle here. So we can draw an obtuse angle for A, B, and C. The angle A is 105 degrees. Angle B is 28 degrees. And side A, it's 20. All right, so what can we conclude here? Anything we can tell? Angle C, it's what? Angle C, the measure of angle C is 180 degrees minus 105 minus 28, which is 180 minus 133. That means you have 47 degrees for angle C. Okay. And since we're given side A, what can we conclude about side B and side C? They must be smaller. They must be smaller than 20. Okay. If you get anything bigger than 20, something is wrong. So you may now go ahead. I think you should be able to do. Find out side B and side C. So you can do side B over, B over sine B. It's equal to A over sine A. All right. So the thing about the application of a law of sines is that you can rearrange them in any order as long as you have the fraction properly written here. You don't know B, but you don't know angle B, which is 28, and A is 20, and angle A, it's 105 degrees. So B, it's okay, so you have B here. All right, so if you do the calculation, you should get that B is equal to 9.72. Okay. Can you all get 9.72? Okay. And then to find out your length C, so we say C over sine C, it's equal to A over sine A. And C is unknown, but we know angle C, that is 47 degrees. And A, it's 20 over sine of 105 degrees. So the good thing about this topic is that it's not so much related to the previous stuff. So it's like something brand new. That means everyone can do it well for this one. And C, it's 15.14. Okay, so does it make sense that your length C is longer than your, or side C is longer than side B? So yeah, it makes sense because angle C is bigger than angle B. So your side C should be longer than side B. So that's how you check the validity of your triangle. Okay, it's just got to make some sense. Okay, angle being greater, the side has to be longer. All right, the next one. Do you still remember how to type in the degree and minute symbol on the calculator? That's the pi button. So so if you draw a little triangle for ABC, okay. So angle ABC, angle A is 49 degrees and 10 minutes. And then angle B, it's 62 degrees and 15 minutes. Then angle C must be 180 minus these two angles. Okay. So 180 degrees minus 1 degrees and 25 minutes. That gives you 68 degrees and 35 minutes. Okay. Yeah. So that's angle C. All right, so that's your angle C. And then you can go ahead and wait, hold on. Side B, it's what? Side B, it's 20. Okay. Side B is 20, then you can go ahead and find out A and C. All right, I'll let you go ahead and try it. Okay. Okay, so if I want to find out my side A, so I would do A over sine A. It's equal to B over sine B because I know both the length of side B and the angle B. So my A, it's A over sine of 49 degrees and 10 minutes. And then my B is 20. And then sine B, it's what, 62 degrees and 15 minutes. So my A is equal to 20 over sine 62 degrees and 15 minutes times sine of 49 degrees and 10 minutes. Okay. Now, if you want to skip this part of the writing, I'm okay. Okay, if you want to skip this part and just put everything into your calculator and solve for A, I'm okay. Because, but I must see this part. I need to see this part. You cannot just start straight to here. Okay, it's a good habit that you write down the equation first so that people know where these numbers are coming from. Okay, it's not just a requirement for points, it's really more of a communication protocol. All right, so you have sine of 20 times sine of 49 degrees. Okay, divided by sine of 62 degrees. All right, so I've got A as 17.098, or I can just round it to 17.1. That's A. Now, I can see that the question does not state specifically how many digits you have to round to. So all I'm asking is that just round to maybe 2 to 3 decimal places. Okay. Don't write out the whole thing. Like, I don't want you to write down 17.09887801. I don't need that many digits. Okay, just give me 1, 2, or 3 digits. That would be good. Decimal places. So that's your side A. And then your side C, okay, would be this. So side C is unknown. So angle C is 68 degrees and 35 minutes. And B is 20 over sine of 62 degrees and 15 minutes. And then C is equal to 20 times sine of 68. Okay, then divided by sine of 62. And I got C being 21.04. 21.04. Which is slightly longer than B, and that makes sense because angle C is slightly bigger than angle B. Okay, so that's how you make sense. That's how you make sense. All right. So just to do a quick recap about the law of sines. The essence here is that whenever you have 2 sides and 2 angles, you can use the law of sines as long as you have one of the 4 things being an unknown. Then you can always use the law of sine. And tomorrow we will learn the law of cosine. Okay, and the requirement's slightly different, and that's how you know. That's how you know when to use what. All right, now on the let's turn to the next page. Okay, now if you turn to the next page, there's a lot of blank space in the bottom. I want you to do something first. Okay, I want you to do something. I want you to draw a triangle like this. Okay, use the blank space in the bottom. Go ahead, draw a triangle. Okay. And then also label the sides. So we have, actually, sorry, my bad. Sorry, let's go ahead and change the letters just a little bit. My bad. And you'll see why I want to do that in a moment. So again, A is the top one, A, B, C, like this. Well, let me ask a question. From when did you learn about area of a triangle? Elementary school? So from elementary school, we know the area of triangle is what? 1/2 base times height, right? So now, so what are we doing here? What are we doing here? Now, let's go ahead and label this as your height. Okay. And I'm going to ask you to do something here. What I would like you to do is this. I would like you to consider this right triangle and this angle right here. And I would like to ask you, based on this triangle, the one I highlighted in yellow, what is sine C? Yeah. So sine C is the ratio opposite over hypotenuse. And if I ask you to express, to solve for height, what would it be? It'd be over here. So if I want you to solve for h will be b times sine c, right? You just have to multiply b on both sides. So now you have this triangle well constructed, and we say, well, how do you find the area of this triangle? Well, this area of triangle ABC, it's 1/2 base times height, right? So base is A, and you'll have your height right there. And let's express the height using this. So A is the baseline, and your h right here, it's b times sine c. So that's why you have the equation at the very top. So I want you to see that this new equation is not really anything new. It's just that when you are not explicitly given your height, we can use this equation. Okay, and this equation is basically telling you that, hey, this is your height. This part is essentially your height. So you still have base times height. Yes. Okay, I think it's very important to know the origin of some equation. Okay, and this one included. So we are not trying to invent something out of thin air. It does have an origin. So we're still doing 1/2 base times height. It's just a height, it's kind of implicit in this case. So that means if you're not given a height, you can still find out your you can still find out your area. Okay, so so if A, B, and C, so we say 97. Okay, A is 8, B it's 9. Now there is one requirement though. There's one requirement, is that the angle must be in between the two sides. That's why we call it the included angle. Okay, so angle must, the given angle, sorry, the given angle must be in between the two lines, the two given sides. Okay, the given angle must be in between the two given sides. Not any angle, but that particular angle. Okay. So in this case, we will say the area, it's equal to 1/2 A, B, and then sine C. So 1/2 8 times 9, and then sine of 97 degrees. You can just go ahead and compute. And you should find out that the area is Okay, 35.73 units square. Okay. Again, the angle must be in between the two given sides. All right, so now the next one, it says the ship it's moving toward a lighthouse. The measure of the angle from the bridge of the ship to the lighthouse is 25 degrees. Let's see. All right, so let me draw a little lighthouse here. Okay, so you have a ship. Okay, so the measure of the angle from the bridge of the ship to the lighthouse is 25 degrees. Okay, later from a point 600 feet closer. Okay, so 600 feet closer. So this is 600 feet. And the angle of elevation is 47 degrees. How high is the beacon above the level of the bridge? Okay. So what we're interested is this length right here. We're interested in finding this length, and this is a right angle. So what can we do? What can we do? Now, first, if you have this triangle drawn, can you write down all the implicit information here? Anything you can label. Okay, the angle adjacent to 47 degrees is 133 degrees. What else? I think we can find this angle as well, right? This angle right here. So we have 180 minus 25 and minus 133. Minus 25 minus 133, and that is 22 degrees. Okay. What else can we find out? This one right here. This one must be 43 degrees. Okay, you have a right triangle, so so that must be 43 degrees. Be a right better. 43 degrees. Okay. So now, this is how you solve a problem. So based on the conditions given, based on the tools that we have, then we ask, well, how do we find out the missing side? Well, let's consider something right here. For this triangle, well, we have all three angles. And one of the side, it's given right here, it's 600 feet. Well, that means, technically speaking, we can find out this length, and we can find out this length using the law of sine. Okay. And how does it help? How does it help? Well, if you have either side right here, and you have a right triangle, then we can actually use a simple trig function to solve it. So let's go ahead and find out. Which side. Let's go ahead and find out this side first. Okay. Let's label some points. Let's just say this is A, this is B, this is C, this is D. All right. So let's go ahead and find out AD in this case. Okay. So we say that the length AD over sine of 133 degrees, it's equal to it's equal to what? We know the 600 feet. And then we also know the 22 degrees, that's opposite. Okay. So you can go ahead and find out AD. Okay, so take a moment, find out AD. So your AD should be 1171.4 feet. Okay. If you know that that's a length of AD, and that should make sense since you have AD across the biggest angle, which is 133 degrees. So you expect something that's much larger than 600 feet. Okay. And then you can say, well, if you have the opposite and the hypotenuse involved, so you can look at the big triangle right there, sine of 25 degrees. It's equal to AB over AD. Okay, opposite over hypotenuse. So AB, it's equal to 1171.4 feet times sine of 25 degrees. So this one, it's using some very basic trig function. And that is 495.1 feet. That it's the height of the lighthouse. Yes. If you consider the big right triangle. Okay. So if you consider the big right triangle, this is A, this is B, and this is D. This is 25 degrees. And this is 1171.4 feet. So you can just use a simple sine function to involve the opposite side and the hypotenuse. And you can find out the missing side. Okay.